Hello everyone, welcome to AI Anytime channel. In this video, we are going to try a new large language model called Zephyr. So Zephyr is an LLM that has been fine-tuned on Mistral. Okay, so it has been created by Hugging Face H4, who are the creators of this model. They also have created models like Star Chat and Flanty 5 Double XL. So they have given us some good models when it comes to open source community. I'm myself is a huge fan of both the mainly the Star Coder LLM for coding problems, and so Star Chat, both alpha and beta was fine-tuned further on Star Coder, and now they have fine-tuned Mistral to get a new model that's called Zephyr 7B Alpha. Now, if you currently see on my screen, it says by Hugging Face H4, Zephyr 7B Alpha. Recently, Mistral has surpassed a few of the LLMs like Llama 2 on the leaderboard. There have been some rumor that Zephyr has surpassed Llama 270B. I have tried Jeppa. To be honest, I am not happy. It's not that good. To be honest, an honest opinion is straightforward. Not a good model to build RAG applications. Very bad in having the understanding of the context. But it works fine for few of the use cases that we can talk about it in this video. We'll try it out. If you see here on the screen, I have a quantized model, which is Zephyr 7B Alpha GGUF, and there have been claims that it has surpassed even 70B of Llama model, which was really surprising. That's good if that has happened. Now, I already have downloaded the model. If you want to download the model, you have to come here in files and versions. You can take any one of these models. They start with 8-bit quantization to 2-bit quantization, which is ridiculous, isn't it? So you have 2-bit quantization now. Imagine if we get 1-bit quantization and then we go to analog AI in 5 years down the line, right? You never know. So there are some real compression and decoding algorithms, and credit goes to the blog for quantizing all these models. Now I already have downloaded the model. You can see on my screen here I have a model called Zephyr 7B quantize 4KS model. It's a small model of 7B 4-bit quantization. Now I'm just going to I'm just going to create a new folder here. So let's create and call it something like J4 Chainlit, because we're going to build a Chainlit interface. So we'll have a conversational interface using Chainlit. We'll try a few of the questions and see how J4 responds. Now the not the original model, but the quantization model. When you compress some models, there are some myths that it degrades the performances of a large language model. Now there is no such proof, I will say, to be honest, but that's how we say it. If you compress something, you might lose some information there. Now, I'm going to open this in terminal, and in this terminal, I'm just going to create a virtual environment here. So Python -name venv dot venv, and then I will go inside this venv. So it will create a virtual environment for you. Okay, so let's go inside cd venv and then go inside scripts. If you are on Ubuntu machine or a Linux distro, you have to go inside bin. Now here I'm going to activate. So let's do activate, couple of cd dot. Okay, and then clean this and open code, VS Code. So we'll first create a requirements file that are required to inference this large language model. We are not going to build any retrieval based or a RAG based application here, like a chatbot on your knowledge base, or a question answering tool, or an agent or your knowledge base. This is basically inferencing Zephyr model using a chainlit application through Langchain. Now here what I'm going to do, let's create a requirements txt. Now in this requirements txt, I'm going to list torch. That's the backend that we need. Then we need Langchain. We need something called C transformers by Marella. If you go on the GitHub repository, you'll find it out. C transformers helps you inference these LLMs on a compute limited hardware or commodity hardwares. Okay, now we have new file formats like GGUF. Earlier we had GGML. Then you have different type of file formats that you can work with. So there are few options that you can select if you want to inference this on your CPU machines, one being Llama CPP. Llama CPP also has a Python binding that's called Llama CPP Python. Then you have Llama, then you have C transformers, etc. Cobol also you can use. So in this, I'm just going to keep it simple and I'm using C transformers. I also tell you that how you can increase the inference on CPU through C transformers. Now, after C transformers, what we're gonna use is Chainlit. Chainlit is a Python library that helps you build conversational interfaces like ChatGPT, where you can write your logic and use LLMs to build a chatbot. Okay, this is what we need. So let's keep it rolling, guys. So here, what I'm gonna do is, oh, I don't know, Python pip install -r requirements txt, let it install, and meanwhile I will bring the model inside this folder. Let me just minimize it over here and let me just drag and drop. Now once I drag the model, I'll just excuse me, I'll just hit enter. Now you can see we have a few things. Now let's start writing the code. We'll keep this video short. So here I'm going to create app.py and I will write all my logics. You can see I'm using GitHub Copilot. It's asked me to write something, but I'm not going to do. Now here the first thing that we're going to import is, let's import operating system. So import OS module. And the next is I'm going to use from Langchain. So we are using Langchain as an orchestration framework. You can also use Haystack or Llama index, that works fine with Chainlit as well. Now from langchain.llms import C transformers. Okay, so C transformers. Now the next thing is from Langchain. Oh, from Langchain, let's import from templates, and LLM chain. We're gonna use LLM chain here. If you want to create your own knowledge base, you through some embeddings model or something, you can use retrieval or conversational retrieval or stuffed QA chain or something like that. Okay, but here we're just gonna inference this Zephyr 7B LLM with Langchain. Okay, using Langchain with the right word. We just want to evaluate a model a bit. Okay, the quantized model, not the original model. Now here I'm just going to write a variable called, not a variable that becomes a constant because you probably will not change it. Now here you have Zephyr, the model. You can see this is the model path. You can also directly use the model from Hugging Face as well. You just have to then give the model path. I'll show you once I'm writing the code. Okay. If you don't want to use Langchain and if you only want to use C transformers, stand alone, you can also do that. You can do C transformer dot from auto-ml dot from pre-train. Okay, auto causal ML. You have to see that the class, I forgot the class name by the way, but you can also use it directly. Sometimes Langchain makes it a bit of slow because it's like an orchestration. You're not directly utilizing the classes. It has its own chains and all, right. It might makes it a bit slow. Now we have our local LLM here. Now what I'm going to do is I'm going to write a config thingy. Let's configure this LLM. Okay, what are the configuration that we have to do? Now inside config, it's a dictionary. So let's define a dictionary here, a Python dictionary. And the first thing is max new tokens. Max new tokens, the number of tokens that we are expecting, the new output, the completions, the responses, whatever. I'm going to keep it 124. Max new tokens. The next thing is I'm going to have repetition penalty. Okay, so let's define repetition penalty. You can see let's keep it the 1.1 standard repetition penalty, and then we're going to have temperature. I'll keep it 0.5. I want it to be creative. Okay, temperature hand controls your randomness and creativity. If you want to evaluate a large language model on the quantitative metrics, you can look at perplexity and burstiness. Okay, yeah. If on quality you want the qualitative measures, you can use RAGAS tools, for faithfulness, the reality, and the factuality, etc., etc. So there are different ways of evaluating LLMs, guys, on your knowledge base if you have. And if you want to use some already created evaluation benchmarkings like human eval and MBPP, you can also do that. Okay, now temperature has been done. The next is top K. So top K, top K here. So let's top K equal to 50. That's right. Copilot is at work now. Top P, let's keep it 0.9, and then what else we have? We can also make it stream equals true. For now, let's keep it if you want streaming responses, but we're gonna handle it. Maybe we can handle it separately on Chainlit through the callback handlers and all. Let's see that. Okay, so for now, let's keep it stream equals true. And then what I'm gonna do here, I'm gonna also explicitly declare that how many threads you should use, of my CPU. So let's do that as well here. So threads, and my threads, what I'm going to do is I'm going to have operating system that I've imported, right? os.cpu count, and I'm going to divide this by 2. Perfectly fine. Now if you do this, it will give you an error because you have to then typecast it as an int. So let's int it here. So int, okay, int, and then let's close it. We don't need this comma now anymore. Now this is our config. Now we'll pass this configuration to C transformers. So when we are utilizing this, loading this LLM. Now let's do that, guys. So what I'm going to do is write a variable called LLM init, and in this LLM init, I'm going to call C transformers, and inside C transformers, I'm going to write model equals local LLM, and then model type. So let's do that. So model type equals, so it's a fine-tuned model of Mistral. So you have to write Mistral here, guys. If you are using a Llama based model, you write Llama. If you are using GPT-2 based model, you write GPT-2. If you are using Falcon, you use Falcon. You have to write a model type. Now model and model type has been done. Now there have been, this is very tricky, right? So if you are using Metal, if you are on Mac, if you are using Kubeless or Blast, those are software, by the way. Okay, now you can all define, explicitly if you want to see or compare the increase in the performances, how fast your inference is. Now I am on a CPU machine right now. I'm not utilizing my CUDA, though I have CUDA here in my machine. But if I just say, okay, use the library, so you can define live here, and you can see the library you can also define based on your CPU, what kind of CPU that you have. Now here I'm going to write AVX2 because that's what I have, that the library that I'm going to pass here. So this depends on what kind of machine you have, and then you can define the library explicitly just to see if that increase the inference speed. Here when I do that, it gives me around 10 to 15 seconds of inference speeds, per response. Okay, but the best way of counting is per token. Okay, but anyway, now let's print this here just to track of it. Okay, say LLM init. And once it is done, now let's do one thing. Let's try it out locally first in terminal. Now I'm going to have a query like something like what is the meaning of life? Okay, this is what I'm going to ask. Okay, to Zephyr 7B, which is really highly rated, though I'm using a quantized model, guys. I'm a huge fan of open source. If you watch my previous 150 videos, 130 of them will be with open source models, okay, on generative AI. I like open source, but you don't have to really hype it something which is really a bad comparison. You cannot rate Zephyr model with GPT-4. It doesn't make any sense, right? GPT-4 is still the best model out there. Now LLM init query, and then oh, we missed after leave. We are not passing the config. Now here we're going to use our config, guys. So you can see double star, and then you can pass all of the config thingy because actually it's a dictionary. So I'm just passing the config here. Now a config has passed, and we don't have anything else to pass here in this C transformers class that we have initiated. Now here I'm passing this query, and I'm just going to print this result. So let's print the result and see what we get here, guys. So let's just print it and see that now. So let's open here in terminal, and here I'm just going to write python app.py. Once I do that, either I will get an error or it will work and give you some response. Okay, in this case right now, guys, we are not using any prompt. Probably we should have used a prompt. We should have used it, but let's see if we can use it when we're writing chainlit code, okay, through LLM chain, right? That's we can do that. Now it will take a bit of time, like 15 to 20 seconds. Ignore this warning here that I'm getting about the depreciations of that Langchain root module is no longer supported. When you run it for the first time, it will take few seconds more. Okay, when you run it for the first time, when you download the models and all. Okay, now meanwhile, what I will also do, I will also import chainlit here. So let me just do import chainlit HCL. Now that is done. Now let's open our terminal and you can see we have got our response. Fantastic. It says this is the one question that has been asked by mankind since time immemorial. It's a difficult question to answer that I believe, it's difficult to explain the meaning of life, and no single theory or answer is universally accepted. That's a good answer, by the way. Now it's talking about Hinduism, it's talking about karma, which is actions, by the way, if you don't know Hindi word. It has dharma, which is duty, are considered the two main purpose of life. I've taken it from Bhagavad Gita or something, in Greek, it also giving you, in philosopher. Fantastic. I love the response, by the way. Okay. Now, but it doesn't mean that it will work for all the knowledge and reasonings and all. Okay. Now let's uh, hash this here, guys. Let me just plug in my charger. And now what I'm going to do here next is, now I'm going to write the Langchain code. So let's write the Langchain code. Now in Langchain, it works always with decorators. Okay, now the first thing that you have to say, okay, so we have CLI Chainlit, and we're saying, okay, whenever you start, okay, so what should be the on chat start? That's first we define it. You write your logic, inside this. So on chat start, you can see it has chat start, chat end, and all this functionality. Now here in chat start, what I'm going to do is I'm going to write a function that will be our main function. So def main, and inside this main function it shows me hello world. This is fantastic. Now let's initiate the chain, for the user session. That's what we're going to do here. So I'm going to write, okay, a prompt. So here we have prompt, and prompt is your prompt template. Let's use a prompt template, and in this prompt template we're going to write our prompt. So let's first define a prompt. So what I'm going to do here is I'm going to define a prompt like template, and in template we're going to write a doc string, and here we're going to define it. So let's do here it, excuse me, here I'm going to write question, and let's define a question here, and in this question it will have your question variable. So let's do a question. Now this is what we are going to ask to model, and in answer what I'm going to write that let's think step by step and answer it faithfully. Okay, something like this. Okay, now we have our prompt template, or maybe the prompt, you can improve the prompt, by the way. I am not a good prompter, to be honest, okay, but I understand few prompting techniques, but you can, again, this is again trial and error kind of a thing. Now in prompt template, now what I'm going to do here is I'm going to write template. So let's use the template, and template is nothing but the template that we have defined above, and then we have an input variable, that is our question. So let's write input variables. So input variables, and input variables are nothing but the question. So we are done with the prompt thingy here. Now let's define an LLM chain. So LLM chain variable, I'm going to use LLM chain from Langchain, and inside this I'm going to write my prompt. So prompt is nothing but prompt that we have an above line, and then we have an LLM. Our LLM is nothing but, as you can see, line number 25, we have LLM in it, and then let's also keep verbose equals true here, just to keep a track of it. Now let's store the chat in a user session, because Chainlit provides you caching mechanism by default. Okay, so it also helps you to track whatever has happened. It keeps something in session in all of your conversation that you had with the chat. It keeps you in the session, and then it uses caching mechanism. Whenever you ask a similar question or the same question, just retrieve the information quickly for you, just to save you some token cost there. Now what I'm going to do here is I'm going to write let's store the chain in the user session, and here what I'm going to do is I'm going to write cl.usersession.set. okay, user session.set, and fantastic. Now this has been set, this will be there in that particular user session. Now what we have done so far, guys, we have defined a template, a very simple one, and just using that, creating a variable called prompt, and just using a LLM chain so far. Now this logic has been done. Now the next logic is on cl.on message. So let's do that. So for that, what I'm going to do is @cl.on message. You can see when we generate the message, and this will be, I'll write an asynchronous function here. So let's define async def main now. Okay, and inside this I'm going to pass my message, which will be going to be a string here. So let's do a message and a string. Now it's an async function. So let's retrieve the chain first from the user session. So let's write it here so you'll understand what I'm writing. Retrieve the chain from the user session. Let's have an LLM chain, get LLM chain. So here we set and here we are get. So here we are setting it and here we are getting that particular chain. That's what we are doing. Now LLM the chain. Now let's call the chain asynchronously, right? So let me just write it. Call the chain let's asynchronously or something like that. Now let's have a result, and this result is nothing but your wait for it. Okay, LLM chain dot a call. I'm using an a call function, and I'm just writing the message, and here I will use the callbacks. If it doesn't succeed, then the callback handler async Langchain callback. It has an async Langchain callback handler function. I'm just going to use that in callbacks. So let's define not callable, callbacks. I think it's callbacks. Now in callbacks, now what I'm going to do is I'm going to write it in cl dot async. You can see it over here, it got it. Okay, and it's a function, so let's do it, and fantastic. Now we are done with our result as well. Let's just return the result, and this varies from chain to chain. If you have a retrieval chain, have a conversational retrieval chain, it will be different, guys. Now here I'm going to write await cl dot message. This will be capital message, excuse me, message. I'm just going to write the content. So my content equals result, and let's only get the text out of it. So result text, and let's send it to the end user. Let me just do that. Now send. That's it. We are done with our code, guys. Here let me just explain you what we did quickly so far with Langchain. So you already have seen this part, print LLM init. Now here we have a template. We have couple of functions. The first is a main function where we are writing our logic, that how it should get executed using Langchain. Now inside this we are writing an asynchronous function for retrieving the chain from the above user session that we have set, and we're calling that chain asynchronously. Okay, with a callbacks handler, which is an async Langchain callback handler, and then just returning the result here over. You can see it. Now we are done with this, so let's run it and see if we get any error, guys. Here I'm going to do chainlit run app.py. Now once you do it, you will see a readme first. Okay, it's a readme, it's a markdown, it creates for you. Now if you look at this, if you come here on chainlit md, you can just remove all of these things, and you can see hi, welcome to Jeppa 7b, and welcome to Inference demo, something like this. Okay, now hi there, let's call it LLM enthusiast. It's a wrong spelling. I don't know how to write it, but so I'll just write it anything. Okay. We are excited to have you on board. Chainlit. Nobody is interested in Chainlit at this moment, on at least on the app that we have built. Credit goes to Chainlit, guys. It's really good to build conversational interfaces like ChatGPT kind of looking. ChatGPT, a lot of things goes in backend, guys. It's not even 5% of that, but okay. Now here, what I'm going to do is let's ask the same question. Let me first do a refresh. Now once we do a refresh, you can see it. You don't have to execute again. It reloads. We are using -w as well. Now here, if you look at it, it said welcome to Zephyr 7b Inference demo. Hi there, LLM enthusiast. We are excited to have you on board. Let's write one more line here in Chainlit. You can ask any question below to get a response. Now let's just run it. Now let me show you something first. You can also go back in settings and come to this mode, which is not the dark mode. Okay, but if you prefer dark mode as I prefer it, I will just make it dark mode. It also has height chain of thought. It will give you all the COT previously whatever you have executed in a chain, that you can also track it. Now let's ask the same question and see if it does anything. Okay, so I'm just gonna do a refresh, and here you can see readme, here you can see chat. What is the meaning of life? This is strange. It says no WebSocket configured. Await handler self. Okay, let me just do a control C and I will run it again. Okay, what is the meaning of life? It says using LLM chain. Now, if you come here, you'll see in because we also tracking as we kept verbose equals to true, it shows you in terminal. It says entering new LLM chain prompt after formatting. What is the meaning of life? And your answer is let's think step by step and answer it faithfully, and your answer will be inside below. Now, it will take 20 to 30 seconds depending on let's see depending on your machine, and we are expecting an answer here guys, that what is the meaning of life. Okay, if you have GPU, of course you can utilize it. C transformer, you have to give GPU layers as an parameter. You can also use here in the code that we have also used in Langchain. Let's see if it gives you anything. Taking a bit longer, probably for the first time it might take a bit longer. Well, let's see it. Okay, and we got our answer. It says the meaning of life is to exist. This means that living organisms including humans are purposefully here, but it does not necessarily mean that there is a specific goal or objective for their existence. However, humans have the ability to think, so it gave you an answer which is quite detailed. You can also use something like stop, or you can parse the output in a better way to end it at a full stop or something. You can also do that. Now, let me just ask a couple of more questions here. So let's ask maybe what is 2 plus 2? Remember, we are using a quantized model, guys, by the way. Okay, so performance will might degrade a bit, not a lot, but a little bit. And let's ask what is 2 plus 2, and I'm expecting that answers would be 4. Let's see that. Okay, so you can also try it out the alpha model. You don't have to use C transformer for it. You can just use transformer through pipeline. You can use it. You can also use it through Langchain as well. Now let me just cut it. I'll give the link in the description, and here you can download the model for inferencing it or building RAG applications. Maybe we can try it out. I tried RAG with Zephyr. I didn't get good success, so I didn't create a video yet so far. Maybe I have to change my approach of uh, creating a RAG application using Zephyr to retrieve better response or to generate better responses. The retriever works fine. It taking around now 40 seconds or something. You can see here. It says so total amount after adding both 2 is 4. It gives you the right result. The question asks to find sum of two numbers, 2 and 2. So we add these two numbers, and let's ask one more question. Like let's ask probably a question from which is little based on reasoning. Okay, or not reasoning. Let me think what kind of tough questions I can ask. Let me take the how to make bombs. This is what I'm asking. This is going to be a last question. I'm just trying to look at does it respond to this kind of questions? If it responds, then we have to write better prompts, to handle this on the ethicality part, how to do to get the results more ethically, from these LLMs. Let's test it out. How to make bombs? Maybe I can also ask. Uh, okay, let's see that. I have a question that I can ask after this, but let's see what it responds to this first. So the code will be available on the GitHub repository, guys. The entire applications, whatever we have built so far, will be available which is a single file, lab.py, that you can go and try it out, and you can also just build uh, retrieval like a RAG application as well. Let me see if I can also create that video very soon, using Zephyr 7b and Langchain. Let's wait for it and see that. When you run it, when we're not running this inside Chainlit, it takes around 20 seconds, at max. When you are running it in terminal, like right, stream when even you do streaming equals to true, you can count the tokens as well. But when we use like Langchain or mainly the Chainlit or something, it takes a bit of time. But I'm very really excited for this answer. What response I get from LLM in this case, Jeppa model. Let's see it out. Ah, it says we should not be making bombs because the purpose of this article is to help people learn a scientific of this article. Referencing to it's referring to some article. You know, making a bomb. Okay, fantastic. Okay, I mean it's okay. We have to improve the prompt a bit. That how should we get the response? Now, let's ask a last question and then I will close after this. I have two. I have a 1988 Ford Mustang. I have a Ford. Let me ask this question. Okay, I have a Ford Mustang that are purchased in 1988. It is more than. Let's ask this question. Can I insure this vehicle? Mainly what happens, guys, right? When you have antique vehicles, you cannot insure this. You cannot list it on policy, right? When you have antique vehicles, now something like more than 30 years or something like that. Let me just see that what kind of answer I'm getting. It has anything like this in the training corpus, the data corpus that it was fine-tuned on? I don't know. I mean, I'm just asking it, and then we'll close after this. Oh, I have a Ford Mustang that purchased in 1988. Can I insert this vehicle? Just to go here, Ford Mustang. My system got hanged. Okay, for whatever reason, maybe due to LLM is taking a hell lot of compute power, on that. Well, let's check it out, guys. I hope I get an answer of. I'm, I'm thinking that I'll get an answer like maybe I don't know or yes, you can insert it. I'm not expecting an answer no here. If it says no, then it's working really fine, to be honest. But as I'm assuming that it does not has seen this kind of question answers or this kind of corpus, in the on the fine tuning steps. Okay, so this is a very complex problem. This is a very complex question that I'm asking to a large language model. Ah, okay. As a 1988 vehicle, you need to provide the current state of your vehicle and proof of ownership. I think I should have asked this question better, but it's okay. Let's read it. You can check with your state department. Typically, when insurance a classic car, you want to choose a policy to cover the vehicle's actual care. Vintage car. Okay. 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 Sounds good. Now, this is what it is, guys, right? I'm okay with it, the responses I'm getting, but when it works, when we are passing the retrievers, the relevant chunks or the documents to it, it's not able to inference in a good way. But on human eval or MBPP and all of those already default questions, right? This LLMs perform good because when they fine tune this or when they train these LLMs, they already know what kind of questions people are asking, like how they are going to evaluate through human eval or MBPP or any other evaluation test. They have all the data there, right? They can feed that in their training step and they can again surpass all the LLMs. But it is fine. You can try it out. I will again create one more videos on this for a RAG application, retrieval augmented generation, for building a chatbot or a question answering tool on your data. Please wait for that video as well. And the code will be available on the GitHub repository. If you have any thoughts, feedbacks, or comment, please let me know in the comment box. You can also reach out to me through my social media channels. Find that on the channel About Us or on the banner as well. That's all for this video, guys. If you haven't subscribed the channel, please do subscribe. You can watch all of the generative AI content in this channel. Okay, please like the video and share the video and the channel with your friends and to peer. Thank you so much for watching. See you in the next one.